So this is a demonstration of my RF transmitters. You can see I have 4 of them. There's 2 on each board. They're hooked to the same power supply, and I have a hub that converts my computer output for each of the Ethernet ports. I'm driving these using E131 multicast, and as you can see I have 16 universe outputs set up in X-Lights with 480 channels on each one of these universes. And the receiver on this is a RF receiver, which you can see here, and I've wired it to the top half of my display. And so we're going to go ahead and start running the preview for X-Lights. As you can see, I'm driving the first display, and then I have the Arduino, and I'm just going to update the RF channel and upload it to the display driver. And this takes about 20 seconds. I'm going to go through all 16 of the universe outputs just to demonstrate it really is working. I'm using RF channels 80 through 95, which in a continuous fashion, so you can see number 2 is working. And the nice thing about driving 4 of the RF channels from each transmitter is there's actually a 3-channel separation between them. So it works really nice, and I can actually drive continuous channels without worrying about interference. Now this assumes that you keep about the same number of pixels on each RF channel. So my card will actually work at both the 256K bit and the 1 megabit level. And you can see I've gone to channel 3, and we'll keep going. If you run at the 250K bit rate, 50 pixels takes about 7.4 milliseconds, so you can drive about 60 to 65 pixels on each channel at 250K bit. If you drive it at megabit, it takes about 2.4 milliseconds for 50 pixels or 7.6 milliseconds for 150 pixels. So you can see there I got channel 5. We'll keep going. So if you use the 1 megabit rate, it's about a little over 30 milliseconds to drive 150 pixels out all 4 channels. And this latency is low enough that I think anything that's under the 50 milliseconds people can't really notice. So you can see I'm on channel 6. So the important thing about my transmitters that I've added is the power isolation. I did a bunch of testing, and I found out that you can't just isolate the power, you need to also isolate the ground. I work with some very bright engineers, and one of them told me if you don't isolate your transmitters, it'll eat your lunch, which I think is funny. And so for those of you that have had issues with range and trying to find the right channel, your real issue is your power and ground. So there's number 7. We're going on to 8. And you can see when it starts uploading it stops. The other thing that's good to pay attention to when you're using these is the materials that you're passing your signal through. If you search on the internet, there's a lot of good information. There's channel 8, a lot of good information on Wi-Fi, which we share that frequency, and how much attenuation you get from different materials. If you go to my website, I have a listing of some of the common materials. And also, somebody on the forum noted that you want to make sure for your enclosures that you don't put the case too close to the transmitters, because it will affect the output antenna, and it doesn't take much capacitance at these frequencies to upset the antenna. So on to channel 10. The other thing to take note of when you use these transmitters and receivers is if you put a donut over them, that's your antenna pattern. And so you don't want to point the transmitters sideways in either direction because it'll create nulls, which will reduce your transmit and receive power. There's number 10. My controllers are rather simple. Just to save cost and minimize parts, I actually use jumpers to configure it. There's 5 jumpers for setting the RF channel, and basically they set every 4th channel. The lower 2 bits are always 0. So you can configure whatever channels you need. But if you go to my website, you'll notice that there's number 11. I show on my website which channels are taken up by the Wi-Fi channels and your microwave oven. So those are good areas to avoid. And also when you set these up, it's a good idea to try and do line of sight. That will maximize your signal. And I believe, just from what I've seen, that you could probably get away with just using the low power transmitters and receivers if you are careful to do line of sight. There's number 12. And so we're almost done. Number 13, and I think we just have a few more and I'll be done. So if you are using the USB transmitter, using these for a USB transmitter, I'd recommend that you just stop at one transmitter with USB. When you go to Ethernet, the Ethernet is ground isolated, and then you'll need to use a separate power supply for each transmitter. And that should resolve your problems with choosing different channels. There's number 14. Sadly, though, I have a lot of materials for doing this wired, so I'm kind of conflicted on whether I'm going to use the RF channels for this next Christmas season. Running the cable does get kind of cumbersome, so I'm actually thinking a combination of RF and wired would work best. You can use the RF for your small displays and remote areas, and then the wired for your big things like your trees. Make a tree. And that would probably give you the best mixture. You can see there's channel 15, and we're going to the last one right now. There's number 16, and so thank you for watching my video from Ron's Holiday Lights. You have a good day.